Yeah, I can see it.
Yes, same.
All right, thanks. Thanks for the confirmation. So welcome to the Zero to CCNP ENCOR class. So in this class, we are going to go through all the topics that we have into the official CCNP ENCOR syllabus. And we'll also see the structure of the exam. Like today is just the introduction. So I'll explain you what is expected into the exam. And then of course, how this course is designed to make sure that you have all the knowledge that you need, what kind of devices are we using, and give you some examples of the topologies and EVNG, so that you are ready to start doing the labs right from the first day that we start. So next week we will start the actual course. So you will have some time to set up EVNG and OVA in case if you haven't done it yet. So this week will be a good time to start doing that, right? So first of all, that is something that we always discuss about initially, is that what is the exact Cisco Enterprise Infrastructure Certification track. So you know that now CCNA is a common certification, no matter in which direction do you want to go. So once you do the CCNA and you move to the CCNP, now they have actually changed the structure. Like earlier, CCNP routing and switching, it used to be called, and there used to be 3 certifications: route, switch, and T-shoot. But now what they did is they changed it to have 2 different type of exams. One is called the core exam, and there are so many different tracks. You have enterprise infrastructure, security, service provider, collaboration, which is voice and video, basically, data center. So you will have to decide which track you want to go for, which stream you want to go for. And then in that particular stream, you will have a core exam for that particular track, a technology core exam. And then you have to pass at least one of the concentration exams. So core exam covers broadly all the details that you need to know about the important technologies, the newer technologies as well. And this is also the exam which actually plays as the qual exam for CCIE lab. So earlier what used to happen, you had to pass the CCNP exam, like route, switch, T-shoot, separate certifications, separate exams, sorry, to get the certification of CCNP. And then you also had to pass CCIE qual written exam if you want to go for CCIE lab. If you are planning to prepare for CCIE in future, you had a completely different exam for that. So now what they did is, if you pass the technology core exam of a particular track, you will be able to directly book the CCI lab also anytime within next 3 years for that particular track. So, for example, enterprise track, if you are passing the ENCOR exam, which is the enterprise core exam, then you will be able to book either CCI enterprise infrastructure, or even you can book CCI wireless. The reason you can also book CCI wireless is because first of all, you will see, like in our course also, we have a little bit of introduction to wireless. But then one of the concentration exam, as you can see, the third one, second one and third one, is designing Cisco enterprise wireless networks and implementing Cisco enterprise wireless networks. So if you use one of these concentration exams, then you are getting a little bit more detail about wireless infrastructure, and then maybe you are interested more in that, and you can go for CCI wireless. You don't need to pass another exam for CCI for that purpose. Your ENCOR exam enables you to book the CCI enterprise infrastructure or CCI wireless exam. But since we are concentrating on enterprise infrastructure, which is just a new name for routing and switching, uh, earlier it used to be called routing and switching. So we have to definitely pass the ENCOR exam, the one that we are going to cover in this course. And one of the concentration exams where we actually cover NRC. NRC is the Enterprise Advanced Routing and Services. So if you pass one core and one concentration exam, then you become CCNP certified. Right? So you just need these 2 certification. So since the ENCOR exam is basically required, whether you want to do wireless or just in-depth routing, or you want to get more detail of SD-WAN or automation, anything you want to do, the ENCOR is the common factor here, right? So that becomes the important exam, or a starting point, I would say. And then of course, then you can move to enterprise lab option. As you can see here, we have wireless or enterprise infrastructure lab. 2 options you get by passing the single ENCOR exam. So this one, as we know, is a complete program. No matter when you join, if you have joined in NRC, then we move to ENCOR, and then we keep on switching like this. So if you have joined in ENCOR, after this we will start NRC. To be honest, it doesn't matter which one you join first, but what is important is that you actually complete both exam tracks. The reason is because they cover routing and switching and advanced stuff, everything. If you are doing NRC and ENCOR both, right? So that's why this program covers both uh, CCNP NRC and CCNP ENCOR. So currently the version that is going on is version 1.1. And for example, ENCOR version 1.1, if you see the syllabus of this, let's see here. This is the official document from Cisco, which represent that what kind of information is expected in the ENCOR exam 350-40. So you will see that there are different sections like architecture, where we need to understand some theoretical knowledge, like what kind of high level enterprise network design means, like 2-tier, 3-tier, fabric and cloud. Some high availability techniques like first hop redundancy protocols that we learn, like HSRP, VRP, and single sign-on redundancy. What exactly these keyword mean? Now, whenever you are reading the syllabus from Cisco website or official syllabus, remember, in exam you may have many theoretical questions, of course, and for that you should practice some practice questions at the end of the course, but you also may have some simulations, right? That means they can ask you some questions where you have to click on the device and you have to configure it. So when you are reading this requirement or this syllabus, you have to pay attention to the keyword. Like here it is saying we have to explain or describe. Again, you can see explain. So these things you don't need to configure. They will not ask you any simulation question on these, because they are not asking you to configure. They're asking you to just describe or explain. That means you should be able to understand this technology. Like wireless, you don't need to configure in the ENCOR exam, but you should be available to understand that, okay, what exactly is the difference between different wireless deployment models? What is the concept of wireless LAN controller and lightweight access points, and the different way we can actually implement this. So these things we are going to learn definitely as well. But then again, there are some certain keywords that, for example, interpret wired and wireless QoS configurations. Now here also, it's a very interesting keyword, interpret. What does it mean? It means that they might not ask you any question to configure QoS, but there might be some questions where there will be QoS configuration and you have to interpret it, you have to understand and explain it, or use it to answer some certain questions, right? Similarly, in the virtualization, you can see we have some describing of different kind of virtualization technologies. Like what is the difference between hypervisor type 1 and type 2? Hypervisor type 1 directly interacts with the hardware, whereas hypervisor type 2 actually interacts with the operating system, and the operating system, of course, interacts with the hardware. So type 1 example would be KVM, which actually you configure on a Linux machine, kernel virtualization machine, and that can directly interact with the kernel or with the hardware. Type 2 example would be VMware, like we're using, which actually interacts with the operating system, not directly to the hardware. So we'll understand all these things, virtual machine concept, virtual switching, and then you see that we have a keyword configure. So here we will definitely need to have labs, and we need to practice so that we know exactly how these things work, like how to configure VRF. Especially we are talking about VRF Lite, because you don't have MPLS into this. Um, so whenever you use the VRF for virtual routing and forwarding without MPLS, then it is called VRF Lite. So what is VRF? Again, we are going to understand in detail, but just to tell you quickly that every router has a routing table, right? And a forwarding table. So service providers, they have to actually service many customers. So in MPLS technology, they created a concept of creating a virtual routing table and a virtual forwarding table, which is dedicated to a particular customer. That means you associate an interface going to the customer and the routing protocol configured toward the customer. You link these things to the virtual routing table. So there is a dedicated routing table for all the routes coming from a particular customer, which will be completely isolated from other routes which may be coming from another customer. So actually you are using a physical single router, but logically it is divided into multiple virtual routers because every router inside has a different routing table completely isolated from other routing tables, right? This is called virtual routing and forwarding. But if you're using VRF in an enterprise environment where you are not a service provider, but you just want to still utilize the single infrastructure, but maybe for multiple different businesses, and you want to keep their routes completely separate, you can use VRF here as well without MPLS. So when you use VRF without MPLS, it is called VRF Lite. And of course, tunneling technologies, GRE and IPsec tunneling, we are going to see and configure and see some labs as. And then again, some important concepts that we use into SDA, which is the software-defined networking on the campus side or the LAN side. So these protocols are used to create the underlay, to utilize the underlay of your network to create an overlay of SDA or software-defined architecture, which is Lisp and VXLAN. So Lisp is used on the layer 3 level, location ID separation protocol, and virtual extensible LAN is used on the layer 2 level. And these two things together create the overlay of the network. So control plane is controlled by Lisp. And then when you're actually sending data into the SDA network, that is actually controlled by VXLAN. You use a VXLAN header for that. So Lisp is control plane and VXLAN is data plane in your SDA implementation. And the best thing you will see is that you don't even need to configure these things. You need to understand it. And when you implement SDA, automatically these things are provisioned by the DNS center or the DNAC that we use to use that we use as a controller, right, into SDA network or software-defined network on the LAN side. Then, of course, you have infrastructural configuration, which, of course, we always have to know layer 2 information, like what is the trunking configuration, ether channels, spanning tree protocol, and some of the spanning tree protocol features. Now, this you can see, it doesn't even say whether we want to configure, troubleshoot, or what we need to do here. So, in detail. So, then you go into specific keywords like configure and verify, RSTP and MST. So this is something, of course, we will have to have a lab as well. Then comes the routing. And in the routing, you can see, although NRC, another certification that is part of the another exam that is part of the CCNP certification, NRC is called Enterprise Networking Advanced Routing and Services, right? So definitely you get much more in-depth routing details into NRC certification. That's why here they are not actually covering it in much detail, but some of the basic information, especially comparing some routing concept between EIGRP and OSPF, configuring of a simple OSPF version 2, version 3 environments, and some configuration of filtering, summarization, and then configuring and verifying only eBGP. That means external BGP between two organizations on the directly connected neighbors. So you don't have very in-depth routing configuration because that is reserved for NRC. But yes, you again, if you have already done NRC, so it will be a good refresher. If you haven't done NRC, don't worry. We are going to start it from the scratch anyway. And then in NRC, it will solidify your understanding even more when you go to the routing protocols. And then you can see, although PBR, it says describe PBR, but we do have a lab so that we can understand it completely, how policy-based routing works, how it is different from the traditional routing concepts, right? So in traditional routing, we always use the destination IP address to decide where to send the packet next. But in PBR, we can actually decide by many things into an IP packet, like source IP, destination IP, source port number, destination port number, which protocol is being used. Are there any special markings into the packet, QoS markings like DHCP or IP header markings, any type of service marking, or is there any specific type of packet is this, like TCP, SYN packet or SYN-ACK? Based on many things, we can decide where the packet will go next, right? So that is called policy-based routing. So before it can go to the traditional routing engine, we actually already decide what will be the next stop. So we'll see a practical of that as well. So I think just to give you an example, we use this topology for most of our practicals, routing practicals. So you will see that we are using 8 routers here. and they are connected in this particular structure. And then every week we'll do some labs. So what will happen is that I'm going to explain you the theory of this of the lab, and then we'll come to the actual practical. So in the actual practical, also in the live session, I'm going to go through the lab. For example, if I'm talking about IPSLA, we are going to have this lab in the exam style, where I'll have some instructions here, what needs to be done, and we are going to configure it accordingly. Basically, what will happen is that in the live Zoom session, I am going to configure the lab step by step, explaining what we are doing, so you can still concentrate on just learning. And then, of course, the same lab along with the solution file, I'm going to send you. The solution is also here and from the second page onward. So I'll send you this file after the class, so that during the week when we don't have the class, you can go through this lab and practice it and see if you can do it or not, right? If there is any issue or anything, you can definitely contact me as well. Wireless, on the other hand, they know, because this exam is not for wireless. There is a dedicated wireless concentration exam, right? Just like NRC is for advanced routing and switching, routing and services. So it's a separate exam. Similarly, wireless is a separate exam. Also, we saw that there are design and implementation two wireless exams. So they don't want to cover much detail here. They just want to introduce wireless a little bit, and that's why you see you don't have any configuration. It is mostly describing some logic and the configuration of wireless. So we'll see that part. But yes, then comes a lot of configuration and interpretation into the IP services part. So network address translation, NTP, network time protocol, FHRP is, as I was talking about earlier, HSRP, VRP, to have gateway load balancing, and multicasting, some information about RPF check, PIM, IGMP, some network assurance. Network assurance basically means checking your network for any issues, debugging, and event management and event reporting. All these things will be part of network assurance. Here also we have quite a few configuration, like configuring and verifying flexible net flow, span, RSpan, ERSpan, IPSLA. Of course, the one lab I just showed you, that was IPSLA, and some introduction to software-defined networking part as well. Like, what is the difference between netconf and resconf? What are these transport protocols, and how are they used into programmability? Right, that is something we'll see as well. So programmability, actually, automation and programmability is also a big part of CCNP ENCOR exam, and we are definitely going to cover the logics and details of different data formats, these kind of transport protocols like netconf and resconf. What is the difference between these two? Which tools we can use to actually send instructions to the routers and switches? That is something we'll see as well. Security configuration, of course, AAA, ACL, COP, all the important security aspect of whether it is wireless or wired, you'll see. And some of them we can configure also. You can see we have some configuration as well. So we have to make sure that we have some labs for these as well. And then we have the automation. So in automation, we are going to introduce some basic Python, like what exactly how Python work. We'll see the data formats like JSON, JavaScript object notation, how these files to be interpreted, how to construct JSON files, or how to read it. Like if you see a file structure, how do you know if it's a JSON structure or YAML structure, or is it XML structure? So we can actually check that out. Also, when you are sending an instruction to the router, which language are you using, right? So you have to have a common language, right? Common protocol between router and the machine that you're using to send the instructions. So we have a data model which is called a language. So data modeling language that we use for programmability is called Yang data model. So we'll see how Yang data model instructions are constructed, and then you send them to the device. So we'll use some tools, like on CLI we'll use curl CURL to send the resconf request to the device. And on the GUI side, we can use Postman. Postman is one of the application we can install on our Windows machine or Linux machine or Mac OS. And then it can actually send resconf instructions to your router to do different things like configuring routing protocols, interfaces, deleting something, modifying something. We can do everything from a central location. And for this, we use netconf for resconf transport protocols, right? But you can actually combine them with your Python knowledge, and then you can create some Python scripts where when you execute the program, it will actually initiate a connection to your router using netconf or resconf, and then configure things according to your requirement. You can create programs where it will be you just need to execute the program and it can do 5 to 10 different things on the router at the same time because it has initiated a connection. So we will see that automation and programmability examples as well. And of course, when we are using this kind of REST API configuration, these can be used to connect to your SD-WAN or SDA implementation and configure different things or query different things as well, which we call the REST API. And we'll see the importance and logic of REST API as well, right? Then comes the Cisco's in-house scripting language, which is called EEM, Embedded Event Management. So EEM is generally used for responding to events. Like if there is an event happening, you can take some certain actions like sending an email to the administrator or logging that information, logging the event, or maybe shutting down an interface or removing some configuration or giving some warning. You can do many things based on what event is happening, but you can actually combine the EEM to your Python programs as well, and then it can become very powerful. So instead of taking an action, it can execute a Python program, which is very powerful language, which can do a lot of things, right? So we'll see what difference is there if we just use EEM versus EEM and Python. And then, of course, we will compare the agent versus agentless orchestration tools like Chef, Puppet, Ansible, and SaltStack, and see what are the pros and cons of using one over the other, right? So that completes our syllabus over 1.1. You can see there are many things we are going to cover, and it's going to be a lot of fun. So we'll get started with that from the next week. So coming back to the certification track, the ENCOR. So this program, Zero to CCNP program, basically, as I mentioned, there's one core exam and one concentration exam, and we need to pass both to become CCNP. And the ENCOR exam, implementing and operating Cisco Enterprise Network Core Technologies, is 350-401. That's the one that is covered in this course, and that's the one that we saw the syllabus, right? That we are going to cover. NRC is something either you have already done it or you can do it after this, where we'll go into the much more detail into the routing part, especially, and some services. That's why we have separate OVS for these. So the OVA file that I sent you for this class is for ENCOR. And if you join NRC later, or if you have already joined NRC, you know that there's a separate OVA for that one. So we use a completely different structure for this one. Now, what about the course structure for this course? How exactly are we going to go every week, and what is expected from my side and what is expected from your side? So it depends on which kind of a structure you're using or which class you're using. You will see that the class can be sometimes 2 times a week or 1 time a week. This particular class is going to be once per session, right? One session per week. So earlier we had some classes with 2 sessions per week as well, but right now you can ignore this one. We only have 1 session per week, and this is going to be 2 hours per session. So I always say in my classes that these classes are not time driven, but they are topic driven. So depends on which topic we are covering that week. It might go a little bit more than 2 hours, or it might even finish well before 2 hours as well. So it's not. It's just a difference for understanding that okay, we have roughly 2 hours class, but it depends on the topic how much time it will take. So here I'm going to in this live Zoom session, I'm going to explain the concepts and showing the lab configuration. So there are 2 things here: in-depth theory, where we make sure that we understand the logic very properly of anything that we are going to configure with all the important aspects of that technology. And then, of course, we will have multiple practical labs. Every week we have a lab, and then that lab actually solidify our understanding of the topic which we have just learned. So in the class, in the live Zoom session, after the theory, I am going to solve the lab step by step. You don't need to do it at that time. You can just concentrate when I'm doing it. And of course, I'm not going to be quiet when I'm configuring the lab. I will be explaining every single step, what they're asking into the question, why we need to do the solution in a certain way. And if there are any question, of course, I'll be answering those questions as well in that part. And you need to do this lab during the week when we don't have the live class. So that's why you will see that the lab PDF will be sent after the session along with the solution file. So for CCNP classes, basically it's a single PDF where the first page is the instructions, and from second page onward you have the solution. So you can actually always refer to the solution whenever you are configuring the lab. Now remember, this class is while you're doing the lab. That time, remember, you have to remember that you still have to have the mindset of learning. So don't try to test yourself when you are doing the lab on your own. Try to learn. So if you get stuck somewhere, feel free to go and check the solution file or check the recordings again, or ask me, and make sure that you understand that topic, or understand the logic behind a certain kind of solution that we have taken. One thing though is that if you see that there are recordings available for lifetime, but these recordings might be from one of the previous classes, because we have many ENCOR and NRC classes going on every time. So we don't keep the recordings from every one of those because the topics are same. So you might see that the recording is from one of the previous class, not from the current class, but the content will be that will be covered is same, right? So you don't need to worry about that part. And we are going to use the EVNG based topologies with multiple routers and switches. So I'll explain you the EVNG in a minute, that how exactly it looks like, and the how are you going to access the OVA file that I sent you. And then of course, all the recordings that we have, you will have lifetime access to those. So anytime we add something new to the course, because there is a modification in the actual course structure, we are definitely going to add it to the online portal. And since you have lifetime access, you will also get that update as soon as possible, right? So for the CCNP ENCOR, we have actually 5 or 6, you can see, different core technology that we need to concentrate on. Infrastructure, dual staking, IPv4 and IPv6, virtualization, network assurance, security, and automation. So we are actually going to go through in detail of all these technologies, or all these things. Like in the infrastructure part, you will see that we have VLANs and trunking, ether channels, so mostly layer 2 stuff and layer 3 stuff. So spanning tree protocol, rapid spanning tree protocol, multiple spanning tree protocols. So this is the switching part. And then we switch to routing, where EIGRP, OSPF, EBGP, and policy-based routing. So this is something we have seen into the syllabus as well, right? So that's what we're going to concentrate as well. In the infrastructure, we also have the concept of wireless LAN, NTP, HSRP, VRP, NAT, multicasting. So these things definitely we are going to cover. Then comes the architecture. So as we have seen that, we'll understand some of the theoretical part of it. You can see that you don't have any configurational usage. Like for example, SD-WAN. What is SD-WAN? SD-WAN allows you to actually use the software-defined networking concept for your WAN implementation, where you can have a controller like a vSmart, and a management GUI, which is called vManage, and an orchestrator, which we call vBond, and how these can be used to actually exchange routes between different locations securely and exchange traffic securely, without configuring the policies on every single edge device. Instead, the policies are created and controlled from the controller, from a central location. So you don't have any practical in the exam. So in the exam, you will not see any simulation lab for SD-WAN or SDA. But yeah, of course, when you move on to CCIE, we will have definitely many labs on SD-WAN and concepts of those software-defined networking there. But here you just need to learn the logic. And of course, QoS and the different types of tables that we use: SEP table, CAM table, TCAM, FibRib, adjacency. What is the difference between these type of tables, and what is the objective of using these different tables? Virtualization, we are going to talk about hypervisors, VMs, virtual switching, VRF, and GRE Lisp and VXLAN. So this is something we have seen as well into the syllabus already. It's the same information, same thing for network assurance and security and automation. So automation, as I was telling you, that we will have some Python components and scripts, JSON structure, and all these things we already discussed, right? So this is something we'll cover directly into the automation and programmability part. Now, which tools are we going to use for this course? So we are going to use EVNG on VMware. So the OVA that I sent you, you need to actually import it into the VMware Workstation Player. So if you have already downloaded and installed VMware Workstation, then it's great. If you haven't done it yet, then you can go to the Broadcom website, because Broadcom has actually purchased or taken over VMware. So after that, the website has become very difficult to find the resources on. So if you have any issue finding or downloading VMware, also let me know. I can provide you the link, our in-house link, from where you can download the VMware Workstation 17, I think, which can be very useful. In case if you already have VMware, you just need to import the OVA, and topologies are already set in the EVNG for that purpose. So just to show you an example, when you import the OVA and you boot the machine, you will see something like this, where you will have an IP address here, like 192.168.79.155. In your case, it might be different IP. And then you will see a login screen. So this login screen is the backend of EVNG. It is the Ubuntu server or Ubuntu Linux server where EVNG KVM is installed, right? So you don't need to log in here technically, but in case if you want to, you can see the username password right here. Default root password is EU. That means the username is root and the password is EU if you want to log in. But there is no need, because if you want to do all the labs that we have in CCNP ENCOR, you just need to open this IP into a browser, and that's where you will see all the topologies pre-built, right? So let's open this IP into the browser just to see an example. So once you come to the GUI like this, you will have the username admin and the password is EU, EVE, right? The name of the software. So admin and EU, that's a different username password from the CLI. You sign in and you go to this particular page. So when you come to this page, this is where it shows you all the topologies that we have that we will be using for different labs. For example, I was showing you the IPSLA lab earlier. We will be using the topology CCNP ENCOR routing for that purpose, right? And then we also have a CCNP ENCOR switching topology. Like if you click on a particular topology, you can click on open, and it shows you all the routers there, and you can go to the more actions and click on start all nodes. Anytime you start a new lab, I would highly recommend to go to the more actions and do a wipe all nodes. What happens with wipe all nodes is that it removes the earlier saved configuration that you might have, and that configuration might be from the previous lab. So you might want to start from the startup config, the base config only, which is just IP addressing. So maybe you configured OSPF and you saved it everywhere and you want to remove it now. You don't need to manually remove it. You can just go and wipe all nodes and it will go back to the base config, which is just IP addressing. And then you can configure the next lab. But of course, if you are in the middle of a lab and you have saved everything so that you can resume from that point onward, you should not wipe the nodes at that point. You should only wipe them when you are going for the next lab, right? So that is something you can always see into the EVNG video as well, which is into the first week of the course. There will something you will see in the pre-recorded sessions. So you go to the more action, then you start all nodes, and then you can start configuring them using the terminal software that you have, PuTTY or Secure CRT or Super PuTTY, whatever you're using. You can use that to connect and access these devices, right? Now the question is that how do you connect to them? So I will also send you a software, or I think it might be part of the OV already, which is the EVNG Windows Client Pack. When you install Windows Client Pack, it's a software from EVNG which allows you to connect to your devices by clicking on them and opening the browser. Opening the terminal software that you're using. Like I'm using Super PuTTY or PuTTY, it connects to the PuTTY like this, right? So if you click on the router and nothing happens, make sure that EVNG Windows Client Pack is installed. And then after that, you need to go to the C drive. In the C drive, you need to go to the program files. And in the program files, we have EU-NG folder, EU-NG. If you have installed the Windows Client Pack, you will be able to see this folder. And here you need to actually install this this registry file, Windows 10 64-bit putty. What this registry file does, it actually connects your browser to the default telnet client, which is supposed to be the putty client, right? Putty is already here. You can see it is part of the Windows client pack, so you don't need to install it separately. And don't worry if it says Windows 10, even if you're using Windows 7 or Windows 11, it will work fine as well. It's not an issue at all, right? So make sure that Windows client pack is installed as well. So as I mentioned already, lab files will be sent every week. Solution file will also be sent along with that. And during the off days in a week, you are encouraged basically to do the labs again. And of course, feel free to contact me in case of any questions. How can you contact me? So Christian must have sent you a link to join the Facebook group as well. So the Facebook group is a good community of students where you can ask questions. And of course, I can answer your question there, and other students can also chip in. They can answer, and they might also benefit from your question because they will see the question and answer. It might actually benefit them as well. So Facebook community group is the preferred method to ask questions and get answers. But also, if you're watching recordings on the 0 2 it.com portal, you will see that every recording has a comment section in below. So if you send any comment there, that also comes directly to me, and I will be able to answer you. And then of course, if other people are watching that video later, they will also see our interaction there, and they might also benefit from it because they might have the same question as well. And of course, the last but not the recommended method is to send me the emails, because emails are not monitored so regularly. We are using them only to send the labs and PDF files and all. So it might, your answer solution might get delayed to get a solution from there, right? But yeah, that is also a last resort. You can definitely use that as well, right? EVNG, I already mentioned that we use EVNG software on VMware. So the OVA I already sent you. How much RAM you should have for this one? Recommended RAM is 8 to 16 gig. Actually, 8 gig should also work, should not be a problem. But 16 gig is recommended one. Minimum is 8. And you should set the network type to NAT in case if you are not receiving any IP. I showed you that screen when you boot OVA, and there should be an IP address in the CLI. That's the IPv you open into the browser. So if you're not seeing any IP, make sure you shut down the EVNG and then make sure your network adapter is set to NAT, and then you should try again, and it should actually start showing you there that it has received the IP address, right? So that's it from my side. Today we had a short session to introduce the course and to make sure that you understand what will be covered into the course and how this course is going to be. It will actually take its course or it take its time step by step to make sure that every week we are covering or concentrating on a particular technology and making sure that we become comfortable with it before moving on to the next technology, right?